All right. So, last chapter, life is good. Try and put it all together now. You'll notice that in last chapter we were doing feasible regions to try and solve all of these systems with constraints. And this is section 4.1, which is called the Simplex method. And this allows us to do a little bit of calculations instead of all that graphing, which I know a couple of you are going to be real happy with. But in section 4.1, all we're going to mess with is just trying to set it up. The next video is going to have lots of steps to it and maybe some confusing questions in it. So hold still with the how do you do all of this from beginning to end, because this is just going to look at how do you set it up from the beginning and get it to the point where you can do some calculations. So you notice that I have been avoiding writing all these little x sub 1s and x sub 2s, even though the textbook writes them. I'm still going to avoid doing that as much as I can, but I am going to need to do some of that no matter what I do. So this is problem number 5, page 269. I'm just going to do it straight out of the textbook. Okay, so if you read through the textbook, what you find out is that we don't want to try and do these as inequalities. We want to try to do these as equations. So as long as my variables are non-negative, then I can actually use the simplex method. But here's what it means. It means that if this is going to be less than or equal to 9, there might be some cases where this ends up being 8.6 or maybe 7.3 because you just don't have enough to make a full quantity of 9. So that means that for this problem, if I want to try and pretend that it's not an inequality and I want to pretend that it's an equation, then I can write that, and I'm going to use 2x plus 6y just because I don't really like those little sub-variables running around all over the place. But I do need that here. I'm going to add a number. It's going to be called the slack variable. So this slack variable for this equation is actually going to pick up the slack of whatever this didn't actually end up to be to 9. So if all this added together only ended up to be 8.6, then this is going to have to be 0.4 to make it 9. If this ends up being 2.3, then this variable is going to have to end up being, what was that? I said 2.3. So what is that? 6.7 in order for it to actually equal to 9. So when you do that, then I'm going to actually make this equal to 9 by putting what we call a slack variable on each problem. Okay, so I'm going to do that with this second problem as well. I'm not going to make it greater than or equal to or less than or equal to 14. I'm going to actually make it equal to 14. So that's going to be x plus 6y plus, not the same slack variable, this is a different equation. I'm going to need a different slack variable for that. And then again, I'm not going to make this less than or equal to 8. I'm not going to make it greater than or equal to 8. I'm going to actually make it 8. So that's going to be negative 3x plus y plus, again, another slack variable for that third equation. Now, we picked up some variables. These have to be non-negatives. So I need to make sure that I go ahead and I add in with my variables to make it non-negative. I need to go ahead and add in my 3 slack variables. So these 3 equations now turn into these 3 equations because we have our slack variables. Next thing we're going to do after that then is set up what we call our simplex tableau. Yeah, I don't know. Woohoo! It's a frou-frou name, so we'll do it anyway. So that means that we're going to put it in our matrix form, keeping in mind that I've got 3 different variables here. So I've got a x, I've got a y, I've got an S1, which is a slack for the first equation. I've got an S2, which is a slack for the second equation. I've got an S3, which is the slack for the third equation. And up here, my max, I've got a Z. And then I'm going to turn that into all of my equal to signs. So what does that mean? That means that I'm going to have a 2 here, a 1 here, a -3, a 6, and a 1. I'm going to have a 1 here, but that slack isn't on any of the other variable equations, isn't on this equation, it's not on the other equations, so those are zeros, and that's going to be a 9 there. And then there's a 1 and a 6, and this is slack 2, so it's not there, it's this one, and there's not a Z in there, so that's a 14. And then this equation has only the slack 3. You should notice this almost looks like an identity matrix. There's no Z in there, and there's an 8. Now you'd think that you were finished, but you're not. There's one more part of it that we need to go ahead and put in there. We need to also put in our equation for Z. So I end up with Z has a 3, a 7, a 0 of the, none of that, and it has a 1 of these. But because this one is not set up in terms of Z of 0 equals, I would have to go ahead and make that 0 is equal to -3x sub 1 minus 7x sub 2 plus Z. So these actually end up with negative signs on them because of the way we have to transform that equation. All right, and that's all you have to do. Put in your 0 here, and we're done. That's all it's asking you to do in this section is to convert it from this kind of information in terms of equations to your Simplex tableau. So let's try it again. I'm going to look at problem number 14 on page 270. Problem number 14. So it says on problem number 14 that I need to look at the maximum daily production of an oil refinery that has 1,900 barrels. The refinery can produce 3 different types of fuel: gasoline, diesel, and heating oil. So I just called G the number of barrels of gasoline, D the number of barrels of diesel, and H the number of barrels of heating oil. And I know that those are all non-zero variables. So that means that I'm going to have G is not equal to 0, D is not equal to 0, and H is greater than or equal to 0. Sorry, those are greater than or equals to. So then where does that leave me with the rest of it then? It says it has 1,900, the maximum is 1,900, so something's going to be bigger than 1,900. The number of barrels that I can produce is going to be bigger than 1,900. So G plus D plus H is going to be less than or equal to 1,900. The next part of it, it says that the production cost per barrel is $6 for gasoline, $5 for diesel, and $8 for heating oil. And the cost has to be, in the budget, is $13,400. So it's got to be less than or equal to $13,400. All right, and then it says the profit equation. The profit equation is $7 for a barrel of gas, 6 for a barrel of diesel, and 9 for a barrel of heating oil. And then it says, how should you maximize the profit? So this is my maximum formula. So then that turns me into, I've got these two equations, I've got a profit equation, and now I need to set up my Simplex tableau. So I'm going to use all of these variables. This one gets S1. This one gets S2. So I'm going to go ahead and put my G, my D, my H, my S1, my S2, and my Z. So this one becomes 6, 5, 8. It's got an S1 in it, no S2s and no Z's, and that's 13,400. This one becomes 1, 1, 1, 0 for slack 1, 1 for slack 2, no S's, and that's 1900. And then the last equation becomes, again, this has not got it set equal to 0. So if this is positive, and yes, you want this to be positive, then each one of these has to be negative. So it's a -7, -6, -9. No slack on that particular equation. A 1 there, and a 0. And again, on all of these problems in section 4.1, that's all it asks you to do is stop right here. So even if it's in the form of a word problem, or if it's already set up in equations, 4.1, stop, you're finished. Let me know if you have any questions on how to set this up, because this becomes a key element in section 4.2.